Hi boys and girls, this is Mr. Sandoval, and here we are with homework video number 8, fall break quick review. Make sure you have your journal. Make sure if you don't have your journal, just get out a piece of paper. Try to make this one quick. Just want you to review some ideas before we come back so you're ready to go. And it's going to be Halloween soon, so cool. All right. Make sure you check your Jupyter grades. Do that after this. Just spend a little bit of time today catching up, organizing your folder. Make sure all of your science papers are pulled out of the wads or random stacks in your backpack and put them in your folder. Don't throw anything away from science. All right. This week's assignment, you should have this in your journal or on a piece of paper. Number 1 to 7. I'm going to give you 7 review questions. All right, and to stimulate your thinking about motion. Speed, velocity, distance, time. We've talked about forces, gravity, friction, potential, kinetic energy, chemical, elastic, gravitational, mechanical energy, nuclear energy. So all these different terms that we've been talking about. All right, here we go. Question number 1. Ready? Let's get started. Pause the video if you need to, more time to think. What kind of energy is represented by fuel, like gasoline sitting in the gas tank, right? Car's not moving, you just have gas there. It's a very specific type of energy that we're looking for, so write that down. I will give you a hint. It's potential energy, but it's a certain type of potential energy. So there, I gave away too much. And it's also the same as what's in food that we eat, all right? The food that we eat has this type of energy that allows us to move and do work later and live, right? Okay, so what type of energy is that? Be very specific. Whoa, watch out. Okay, number 2, what kind of energy, be very specific again, is represented by these skiers high up on top of the ski ramps, okay? What type of energy do they have before they start skiing? Just standing up there. All right, number 3. This is an accordion, and the musician will squeeze and stretch the accordion, and that allows him to have to create sound energy, to create sound. So what is this squeezing and stretching? What type of energy is that? Okay, the squeezing and stretching, or when it's squeezed, it has a certain type of energy that allows it to stretch. So what kind of energy would that be? All right, number 4, this is a 3-parter. So let's think about what are the different types of energy transfers in this scenario. Starting with A, up here, the guitar player physically, the strings physically vibrate when they strum. Okay, so the strings are vibrating. What kind of energy do they have in that instant as they vibrate? Okay, not talking about kinetic energy. It's a little bit different. It's a form of kinetic energy, but it's when the physical objects move. All right, now that causes a signal to be sent through the guitar cable. All right, through the guitar cable to the amp. So what's that form of energy that is traveling through the guitar cable? All right, so write that down for letter B. And then that signal from the guitar cable, that energy gets transferred into a different energy by the speaker and then leaves the speaker. So what kind of energy would that be? All right, so you have 3 forms there. Write those down. A turns to B, turns to C. Write that down. Again, pause the video if you need to for a second. All right. Number 5, Newton's law. You have these 2 rams and they're just about to butt heads. They're fighting and they often just come to a stop, or one's trying to push the other one back. So which of Newton's laws, 1, 2, or 3, would be best represented by this one, where 2 forces come together like that? And give a reason why. You have to justify, okay? That's number 5. Which of Newton's laws? Okay. And number 6. Here is a graph showing distance on the y and time on the x. Distance and time. Talking about speed and velocity. So what's the average speed at 3 seconds? So at 3 seconds, you got to figure out the time. And then at 5 seconds, what's the speed? So did it change its speed? Okay. So you have distance, you have time. I'm not going to give away that more than that, but you got to know the formula for calculating speed at those 2 times. All right. And finally, number 7, here's a scenario. A Little League was trying to figure out if the players were getting better at hitting each year after the league started in 2005. So they decided to count the total number of runs scored in all of the games, just to see if are all the teams hitting better and scoring more runs. Maybe that might reflect bad defense too, but that's not what we're looking at. So in this graph, what's the dependent variable and what's the independent variable? All right, write those down. All right, so there's your homework video 8, 1 to 7. And the last thing, make a quick action statement. What is something you are going to do in order to improve? Don't be vague like, I'm going to do all my work. Everybody knows we want to do that, but be more specific. What's one specific thing you need to do, physically do, in order to improve something? What do you want to improve? Think about your academic classes at school for quarter number 2. And that's it. Thanks for watching. Get that parent's signature, organize your binder, get everything organized before we come back to school, and we'll have a happy Halloween when we come back. All right, bye.